Alright you guys, so in day 16 we are still following the distress signal, but instead of being welcomed by a group of elves at the origin of the signal, we find a group of elephants. But the bigger problem is that we are inside a volcano that is about to erupt and we have just 30 minutes to figure out how to solve today's puzzle. So simply put, we have a graph which is like a map in the cave system, and in each chamber we have a valve that can release some amount of pressure, which will give us some time to escape. The issue is that we can travel at a limited speed, so we can move from one chamber to another in 1 minute, and to release the pressure we require 1 minute to open the valve. And one small note is that after we open a valve, it remains open, so we don't need to go back to that chamber again. And for the first puzzle, the question is how much pressure would be released if we travel optimally in 30 minutes. Then for part 2, the elephants prove to be a bit helpful, so they think that one of them can help us to split the search in half. But to be able to help us, we have to teach one of the elephants how things work. So we have to waste 4 minutes to teach them, and we are left only with 26 minutes to find the maximum amount of pressure that two people can release. So yeah, basically for the second puzzle, we are asked how much pressure we can release in 26 minutes if we work together. So the puzzle input looks pretty weird, like it's a lot of text, and the idea is that we have the name of the first chamber and then how much pressure it can release in 1 minute and to what other chambers it leads to. So we can easily build a graph from this structure. So to the source code. Basically I represented each chamber as a pair with two fields. One will be the name and the other one will be the data that it contains, basically the flow and the neighbors. Then to parse a single line of the input, it looks pretty ugly, but I just split the string by space and then searched for the name of the chamber. Then I got the flow as a usize, and then I split the numbers by comma, so and build the vec and then return the pair. Then I wanted to filter a bit the graph because we are told that there are chambers which release zero pressure, so there's no point in visiting those valves. And I also wanted to compute the distance between each node. So for example, if A goes to B and then B goes to C, then you can also go from A to C but in 2 steps. So I also wanted to pre-compute the distances for the entire graph. So basically in this function I found all the non-zero chambers and I also inserted the initial chamber here because usually I saw that it has a flow of 0, the starting point. So first I filtered out all the zero flow valves and then I inserted the initial chamber into this vec, mainly because I saw that initial chamber will always have a flow of 0. So then we have to build a 2D array that will represent the connections between each two nodes, and because we are using strings as indices, I used hash maps to build this 2D array, and we initialize it with the maximum value like infinity. Then for all the combinations of edges that we know they are connected, we initialize the distance with 1, and also I guess that the distance from one node to itself is 0. And I know that this is some classic algorithm for finding the best distance between two nodes, but the main idea is that if we find a road from I to K and then from K to J, and this road is smaller than our current estimate, which at the beginning will be infinite, then it means that we can approximate the distance from I to J with that sum, basically with the road from I to K plus the road from K to J. I mean, yeah, I don't know if it makes sense, but the main idea is that we want to find the distance between each pair of two edges. And then here I decided that it was weird to work with strings as names, and I just converted everything to work with indices. So instead of having to nested hash maps, I changed to working with nested vecs, which I guess it's easier. And yeah, basically this function will just give us the mapping from the name of the node to its index. It will also give us the distance from each pair of nodes, the flows of the valves, and the starting index, which will be 0 because AA will be first. Then I have implemented the solution using dynamic programming, which, yeah, I guess it was really hard, but I got it to work somehow. So we require this DP 3D array that will store the maximum flow that we can have at some point, and we can index this array using the time that has passed in the beginning, the location where we are currently, and we can also use a bit set that will represent which valves are open. And the idea is that since we have very few valves, we can use a single number for that to represent in binary which valves are open. So we initialize this cache with minus infinity, the minimum I64 value, and then for the initial place that we can be in, we put a 0. And yeah, basically this will be the starting location, which was the AA chamber, or any other location that we can reach from the beginning, but we have to keep in mind that it will take us like these steps until we reach there, so we also add that in the initialization. Then we have to compute all the values in the DP array. So we will have 3 loops for all indices. Then we compute the current flow that we would get if we are in this combination, and this is because the pressure is always released no matter if we are in that chamber. I mean, if we already open the valve, it will always be released. Then we check that if we do nothing for a minute, if the pressure gets better, and if it gets better, then we update the current value. Then we have to check the other option that we have, which would be to go in all location that we can reach from the current location. However, if we already opened a valve in that place, we can skip that location because there's no point in moving again in that chamber. So the time that it takes for us to reach in that chamber is basically the distance to that chamber. If the time is larger than what we have left, then it means that we can't do anything about that, so we just skip that valve. And yeah, if the work is worth it, then we just update the state of the next chamber to this amount of pressure that we release. And basically the next state will be indexed by the time that it takes us to reach there. So we increase the current time plus the distance. The location will be just the location of that valve, and because we open the valve, we also bitwise or the bit mask with the value of this chamber. And yeah, for the first part, we just want the maximum value for the 30th minute. So we index the DP by the index 30, and then we go through all the combinations of in which room we ended up and which valves we opened. So for the second part, the idea is that we want us and the elephant to open different sets of valves. So in this case, the I and J indices will represent the bit masks that we want to check. So we can assure that we will open different valves if the bitwise end between these two masks will be 0. So yeah, then we have to index the 26th minute because we lost 4 minutes to teach the elephant, and we still want to get a maximum value from that DP array. And yeah, basically the answer will be just the sum of these two values. So yeah, basically this was the 16th day. In my opinion, it was hard, but I'm not really good at algorithms. But if you want to find or look at the source code, you can find it on my GitHub, and see you next time.